Hey guys, and welcome to your next Advanced C++ and Graphics tutorials. Today what we're going to be doing is implementing the SpriteBatch class, and what this class is going to do is it's going to allow us to batch a bunch of different sprites together in a single draw call in one VBO, basically. Right now we actually have a separate VBO for each sprite, and we're doing a different draw call for each sprite, and that's not efficient at all. And it's actually going to slow down a whole lot once we get upwards of a few hundred sprites. Before we jump into that, oh, and I should mention that the SpriteBatch is actually going to be based off of C# XNA's SpriteBatch class, so it'll work kind of similarly to that, but it'll be for OpenGL. A few things we need to correct in the previous tutorials. First, the SDLA and SDLD keys for moving the camera are backwards, so go ahead and flip that around. Just change one to negative and the other to positive. And then also what we can do is we can change graphics tutorials to depend on Bingen, so we don't have to keep remembering to build Bingen. Just right click on graphics tutorials, go up to build dependencies and then project dependencies, and then click on Bingen, and now anytime we build graphics tutorials, it should also build Bingen, just in case we make changes to Bingen. Another thing, if you go into Bingen and you go to the properties, I told you had to link the libraries. You actually don't have to do that. If you go to librarian and you go to additional dependencies here, you should have a bunch of lib files here. You can delete all those. And also you can go to C++ directories and you can get rid of the library directories path. All we need is the include directories path. So make sure you leave that one the same. The reason we don't need to link any libraries is because we're already linking the libraries in our graphics tutorials project, so we just don't need to do it twice. Anybody who does use your engine will have to link to all the libraries in their project though. Alright, so let's go ahead and get started. We are going to also learn something new today. We're going to learn about what a vertex array object is. Let's go ahead and go to our Bingen and make a new class. So we're going to add a class, and this will be the SpriteBatch class. SpriteBatch. Like that, go ahead and finish. Alright, and let's go ahead and enclose this in our namespace. So we're going to say namespace Bingen. Like that. And I'm actually going to start moving these to the left instead of having them tabbed in. I actually think I prefer it to the left. You can do it either way. If you want to make everything go to the left, just highlight everything and do Shift Tab, and that should do it. And let's go to SpriteBatch.cpp and do the same thing. Namespace Bingen, and it's going to automatically indent for us, but we can undo that if we choose. There we go. Alright, so here is our basic SpriteBatch class. It's not really doing much right now, obviously, so let's go ahead and give it a few methods. First, what we want to do is we want a SpriteBatch.begin call, so we're going to say void begin. Don't worry about the parameters for now. We also need a void end, and then we need a void draw, and we need a void render batches. We'll just say render batch. Let's see, begin, end, draw, render batch, and let's also do a void init. Alright, and these are all our functions. We need to give them a few parameters. So first let me explain how you're actually going to use this. First thing you're going to do in your main game is you're going to create a SpriteBatch class, and you're going to initialize it with the init function. And then you're going to call, whenever you want to draw, you're going to call SpriteBatch begin, and that's going to set everything up and get it ready for drawing. Then after you call SpriteBatch begin, you're going to call void draw on all of the different sprites that you want to draw, and that's going to add them to this batch. It's not going to actually draw them to the screen yet, it's just going to add them to the batch. And then you're going to do void end. This will do some post-processing stuff like sorting all of the different images. And then finally you're going to call render batch, and that's going to actually render it to the screen. That's going to actually finish and draw it all to the screen. So we need a few things down here in the private variables. We're going to need a VBO ID, so we're going to say GLUint, and we'll say just VBO. And we need another ID that we haven't learned yet, and let's of course include glue. Glue up here. And so we have a GLUint VBO, and let's also have a GLUint VAO. Now I'll get into what a VAO is a little bit more in a minute. Let's see, we have init, VBO, VAO. We're going to need a vertex definition, and let's go ahead and just use the vertex definition for our sprite class. So let's go into sprite.h. I believe we put it there somewhere, or maybe we did it in sprite.cpp. Where is our sprite vertex? Vertex data, where is this defined? This is defined in vertex.h, so we can just include vertex.h. Look at us, include, we're going to say vertex.h, okay? So this is going to hold all our vertices. Now what we're going to be doing is we're going to be creating this another little class called a glyph. So let's go ahead and make another class here, class glyph. And what this is it's just a single sprite, essentially. It's going to have the 6 vertices that we normally have for a sprite. It's also going to hold what type of texture it's going to use, and it's also going to hold the depth. And I haven't really taught you what depth is, but if you want to actually have certain sprites appearing in front of and behind other sprites, you need to use depth for that. So let's go ahead and construct our little glyph class, and this can actually be a struct since it's not going to have any methods really. So let's go ahead and give it some vertices. We're going to say vertex, and we'll say top left, vertex bottom left, vertex top right, and vertex bottom right. So there are 4 vertices here. What we're actually going to do is duplicate 2 of the vertices before we draw them to get all 6 vertices. Now we also need to keep track of what texture we're using, and remember textures can be stored in a texture ID gluint, so we're going to do that. We're going to say gluint texture. And then let's also store the depth, even though we probably aren't going to really use it just yet. We'll just have it just to have, so float depth. So this is a glyph. Now we need to have this structure simply so we can sort our glyphs. We want to be able to sort glyphs by texture because each batch that we draw everything in the batch has to have the same texture. Now this is called a SpriteBatch, but it actually might end up being multiple draw calls, multiple batches, because the user might call draw with several different textures, and each of those textures needs to get its own draw call. What we need to do is make sure that all of the like textures are being drawn at the same time so that we can minimize texture switching and minimize the number of draw calls that we have to call. All right, so what is draw going to take? Let's go ahead and start here. Well, it's going to need to give us a little information about what we're drawing. So let's draw it as a rectangle, right? We're drawing a sprite, so we're going to need a position, and we're also going to need a width and a height. So we're going to say glm vec3, and let's go ahead and include glm. glm, and then glm.hpp. Because vec3s are awesome. So this is a 3 component, or actually a vec2, since we're just doing 2 dimensions here. We're going to say glm vec2 position, and then we'll say glm vec2 dimensions, like that. And let's also do the UV coordinates for the texture, and we're actually going to send this in as a, let's send it in as a vec4. Let's actually send both of these in as a vec4. The first 2 components will be the position, and the next 2 components will be the dimensions. So we're going to say glm vec4, and we'll say destination rectangle. That's what that stands for. Destrect would be destination rectangle. And then glm vec4, we'll say UV rectangle. That's the UV coordinates with the bottom left-hand corner and the dimensions. And we also need to say what texture we're going to use. So we're going to say gluint texture. And we also need a color. So we're going to say, oh, that's right, we need to have, I believe we are doing, here we go, we have our color struct. So we'll just pass in a color struct. Color, color. Like that. And that is perfect. Now, as it stands, these parameters are all going to get passed by value. So what's going to happen is when we make this draw call, it's going to have to copy 4 variables here, 4 variables here, a variable here, and then 4 variables here. Instead, what we can do is use it by reference so that we don't have to make that copy. That makes it a little bit faster. But since we're making it by reference, and we only need to do it for things that are multi-byte quantities like this, or multi-variable quantities. This gluint texture is just 1 variable, so you don't really need to do it for that. For anything that we make a reference, we need to make sure that it's not going to get changed because that's going to change the original copy. So what we can do is write const in front of it. And that will make it so that it's a reference, so that it's nice and fast when we pass it, but it's not going to get changed in the original location. Now the compiler might optimize this for us anyways, but it doesn't hurt to do it like this. All right, so that will do the draw call. Let's go ahead and copy some of these. We're going to probably change a few of these parameters. Let's paste it in SpriteBatch.cpp and put SpriteBatch : in front of everything. There we go. And put our curly braces. This is going to be a long episode, I'm sure you've already noticed, but that's okay. This is going to be a really educational episode. All right, so there is draw. Now what draw is going to want to do is it's going to want to add a glyph to a vector of glyphs that we're going to store in SpriteBatch. So let's go ahead and give ourselves a vector of glyphs. So we're going to say std vector, and let's go ahead and include vector at the top. We're going to say std vector of glyph, and we'll call it glyphs. Okay, and it's going to start out with the 0 size. Anytime we call draw, we're just going to push back a new glyph. And there's actually a really fast way to do this. I'll show you about this function called emplaceBack. First I'll do it kind of the slow way, and then I'll show you how to do it the fast way. So first let's make, actually we'll just do it the slow way for now. I'm not going to teach you, the other way doesn't really matter too much for right now. That's fine. So glyph, new glyph. This will be our new glyph that we are constructing. So what we need to do is we need to first, let's go ahead and set up its texture and its depth. So we have texture, we also need to pass in depth. I forgot something. I'm going to say float depth. Let's go ahead and copy that. Float depth. And it's drawing good. So new glyph dot texture equals texture. New glyph dot depth equals depth. Now let's go ahead and set up the vertices. So we're going to say new glyph dot top left. Let's go ahead and set up top left, and its color is going to be equal to color because all of them are going to have the same color. And let's go ahead and just copy this to make it fast. And we're going to say dot position. Now position is a float 2, I believe, or a vec2. Position is 2 floats, yes. So what we can do is just say position.x equals destrect.x, and then position.y equals destrect.y. And now we need to actually, what else do we have? We have UVs. Oh, we actually have a set position. I forgot about that. Let's go ahead and call set position. We're going to say destrect.xy. Once we do this one, we can just kind of copy paste a little bit of this to make it faster. Of course, copy pasting does cause bugs. Keep that in mind. All right, and so we have set color, or we have color, set position. Let's do set UV. Now this is actually the top left. So instead of just y, it should be y plus UV rect dot. And now the components are, if you're doing x, y, and z, it's going to be x, y, z, w. Which is the same as 0, 1, 2, or 3 if we're treating it as an array, which you can do. So the y component of the dimension is going to be the 4th element of UV_rect, which in this case is w. Or you could also type 3. Either one works. We're going to say .w. So that sets the position correctly. Set UV, we're going to want the UV coordinate of the top left. So it's going to be UV_rect.x. UV_rect.y plus UV_rect.w. And that should be it. I believe that is everything we need to set here. Yes, it is. So now let's do the other vertices. 1, 2, 3, 4. So we need to make sure that we, all of these that say top left, they need to be changed or we're going to have a bug here. So this should not be top left, this should be bottom left. So let's copy that. Remember, copy pasting is very dangerous. I just copy pasted a bunch of incorrect stuff. You have to be really careful that you fix everything, and I really would not recommend copy pasting normally. Bottom right dot color, and then we'll do top right. And now let's go ahead and change the position. So bottom left is going to be just XY. Don't need W there. Bottom right is y is at the bottom, so we don't need plus, but we need to add the dimensions for the x. And just to visualize this, let's go ahead and make sure you guys understand what I'm doing here. I'm going to draw a little box. Here's our sprite. Here is top left. Here is bottom left. Here is bottom right, and here is top right. So this is where desdirect xy is pointing to. So if you just said desdirect xy, it would be right here. So desdirect.x and .y. I'll just write it like that. Now, this distance right here is desdirect.w. That's what that distance is. So if we add desdirect.w to desdirect.y, you will get this point up here. And then this distance right here, this is desdirect.z. And it's also the same as desdirect2. And x is desdirect 0, y is desdirect 1. It's essentially just an array of 4 floats. Okay, I hope that makes sense. Don't save. All right, where were we? Bottom right, so we need desdirect plus desdirect.z for the bottom right. And same thing for uvrect plus uvrect.z. And for top right, we're going to have plus for both of them. So we're going to have plus desdirect z and plus uvrect z for the x, as well as adding in the y direction. All right, so that sets up our new glyph. And finally, we just need to add the new glyph to our vector. So we're just going to say glyphs.pushback new glyph. And that will add the new glyph to the end of the vector. Really nice. Now, a better thing to do might actually be to use it as a pointer. And the reason for that is the glyph struct has a lot of data in here. There's quite a few bytes. And when we want to go and sort this, we're going to have to sort a whole bunch of bytes in memory. However, if we change it to just a glyph pointer, a single pointer is just a 8-byte or a 4-byte quantity instead of this huge quantity, which would mean we only have to sort the pointers instead of having to sort all of the huge glyph structs themselves. And that means we have to use new, we have to call new, so we're going to say glyph star new glyph equals new glyph. And this means we need to remember, because we're not going to use smart pointers, we need to remember to delete it. If we don't remember to delete it, then we're going to have a memory leak. So we can quickly fix all these errors here by saying Control F and highlighting all of it. And type in here, we're going to search for new glyph dot, and then we're going to replace it with new glyph arrow, like that. And make sure this says selection here, and it will replace all of the new glyph dot with new glyph arrow and fix the bug we had. All right, and that will push back to glyphs. Perfect. So there is our draw function. We are partially there. This is quite a large class here. Let's go ahead and work on the init function now. What we need to do with the init function is we need to, first we need to create our vertex array object and initialize our vertex array object. So let's go ahead and do that. Let's make a new function, void create vertex array. And I will teach you what this is here in a second. Let's go ahead and copy that down at the bottom here and set it for SpriteBatch. This is what this is going to do is it's going to create our vertex array object. And one thing we should also do is initialize VBO and VAO to 0 just to indicate that they have no attached buffers. So VBO 0, VAO 0. Always a good idea to do that. All right, so now create vertex array. So what is a vertex array object? Well, what it is it's a type of object that encapsulates all of the state that we need to do rendering with OpenGL. So if we go to our sprite class that we made, you'll notice that every time we draw the sprite, we've got to do a bunch of things. We have to bind the texture, we've got to bind the buffer for the VBO buffer, then we've got to enable the vertex attrib arrays, and it looks like we're actually only enabling 0, which is a bug, actually. This should be 0, 1, 2. I'm surprised that worked at all. And we should disable 0, 1, 2. I believe we added that in the texture tutorial and never fixed that. So yeah, you have to enable the vertex attribute arrays, you have to set the vertex attribute pointers, and then finally you draw and you got to disable everything. Well, each of these OpenGL calls has a bit of an overhead. It's going to slow down your game slightly. Now, instead of making all of these calls every frame, what we can do is take all of these calls and put them inside what's called a vertex array object, and it will hold all this state for us. And then all we have to do is when we want to draw our triangles down here, instead of doing all this crap, all we got to do is say GL bind vertex array with our vertex array object, and that's all we have to do since it'll already all be set up for us. So that's what we're going to do with SpriteBatch. It makes it a little bit faster, a little bit cleaner. So first thing we need to do is generate our vertex array object. So GL gen vertex arrays, and we're going to generate one, and we're going to pass in a pointer to VAO to generate it. Next, and I put an extra comment in there. Next, let's go ahead and generate our vertex buffer object. So we're going to say GL gen buffers. We're going to generate one buffer, and we're going to pass in the address of VBO, like that. And we actually only want to generate these if they haven't been generated already, which means if they are not, if they are equal to 0. So let's go ahead and check that just in case somebody tries to call init twice. So if VAO is equal to 0, because if it's not equal to 0, we're going to have a little bit of a memory leak on our hands because we're going to be generating more vertex arrays and more buffers than we actually need if VBO is equal to 0. Just like that. That's why we initialized it to 0. All right, so that will generate both of them. Now after we generate the vertex array object, let's go ahead and bind it. So GL bind vertex array. And binding it means that anything else that you do to change the OpenGL state in here is going to be stored in the vertex array object. So now if what we do is we call GL bind buffer, and we bind the, we'll say GL array buffer, and we're going to bind VBO. If we do that, now what's going to happen is anytime we rebind vertex attribute array, it's automatically going to bind this buffer for us. So we no longer have to call GL bind buffer in our draw call. Now let's also do some of the stuff from Sprite. Let's go ahead and copy this stuff. Let's get rid of these here. Everything except GL draw arrays, and we don't need to disable it anymore. It's just going to always be enabled when the vertex attribute array is bound. So we're going to grab this portion right here, and we're going to put it right in here in create vertex array. And this will, we're going to end up using the same shader for this. So this is going to set up everything with the state that we need. And then finally, we need to go ahead and unbind the vertex attribute array. So we're going to say GL bind vertex array with 0. And what this is going to do is it's going to disable all of these, it's going to unbind our VBO and everything like that, and the next time we bind VAO, it's going to enable all this stuff for us so we don't have to make all those expensive calls. Really, really nifty. Alright, so let's go ahead and call create vertex array whenever we call init. We'll create our little vertex array, and let's also go ahead and, I guess that's it for init right now. I'm trying to make this as simple as possible so we can get this done kind of quickly. Now let's work on SpriteBatch : begin. Now what SpriteBatch : begin is going to do is it's going to basically set up any state we need to actually begin rendering. And as it stands right now, it doesn't look like there's much we need to do there. However, in SpriteBatch.end, we are going to need to do some stuff. We are going to need to try to sort the glyphs, and we are going to need to generate batches from the glyphs. We're going to have to figure out what glyphs are going to be drawn together in the most efficient way. So what we should do here is in SpriteBatch begin, we should tell it basically how we want it to sort. And to do that, what we should do is we should create our own enum class that has all the different kinds of sorting that we can do. So let's say enum class glyph sort type. That seems like an okay name, and we'll tab that over. So we have none, which means no sorting. We're going to have front to back, so sorting from front to back. We're going to have back to front, and we're going to have texture. And whenever it's set the texture, that means it's going to sort them by texture so that all of the same texture gets drawn together. And that's probably what we're going to usually want to do, because that's typically the most efficient way to do this. Now we also need a function for sorting glyphs. Let's go ahead and make a function for that. Void sort glyphs, like that. And let's go ahead and store the current glyph sort type in our private variables here. So we're going to say glyph sort type. Now, whenever we call SpriteBatch begin, we're going to pass in the sort type. So we're going to say glyph sort type, and we're going to say sort type. And what we can do is we can go ahead and set this to a default value. Let's go ahead and do that. I think I've showed you what default parameters are. I'm almost positive I did, but essentially, if we make a default parameter, whoever calls the begin call doesn't have to actually fill in the parameter. If they don't, it will use the default value. So let's go ahead and set it equal to glyph sort type texture by default. Texture, just like that. And let's go ahead and copy. We only have to copy the first part. We don't have to copy the whole thing. But what we can do is copy the whole thing and just comment out the second part so we know exactly what's going on. So we can do this here, just like that. And this is telling us that we have a glyph sort type parameter, but it's going to be set by default to glyph sort type texture. And all we're going to do here is say sort type equals sort type. For now, that's all we're going to do. Okay, looking good. Now in SpriteBatch end, let's go ahead and start by sorting all of our batches. So we're going to make our function call to sort glyphs. Let's go ahead and copy this down below create vertex array. And let's set up this part. All right, so I'm about to teach you about sorting. This isn't something I've done yet. You're going to learn a lot in this episode. I probably will end up splitting this into 2 parts since it's so long. And let's see, so the sort type is already known. It's a private variable. So what we need to do is we need to sort based on what our sort type is. And what we can actually do is we can use a pre-made function, an std function, in order to sort. There's this function called std sort. Std sort, where is std sort? Let's try include cstdlib. I believe std sort should be in here. We don't want qsort, we want sort. Give me just 1 second. Okay, so sort is stored in algorithm. So include the algorithm header, like that. And now we can actually use std sort down here. There's actually 2 sorts. There's std sort and there's std, let's see, stable sort. Stable sort. So we're going to actually use stable sort. The difference between the two is stable sort guarantees that 2 elements that are equal will retain the same order. And that's useful for us. It makes sure that if you want to draw one element before another and they have the same texture, it makes sure they're going to be drawn in the right order. All right, so here is our sorting function, and we actually need to use a different version of this stable sort here based on what our sort type is. And we're only going to sort if it's front to back, back to front, or texture. So let's go ahead and do a case statement, or switch case statement. So we're going to say switch, and we're going to say sort type. All right, and let's say case glyph sort type back to front. We'll do a break in here. I know this is yelling at me, just put a semicolon there for now. And let's go ahead and just copy this 2 times. We have back to front, we have front to back, and then we have the texture sort type. So what stable sort takes is the first 2 parameters are an iterator to the beginning of your container and the end of your container. In vectors, you can get an iterator with a vector, and we use front and back just like with lists or anything like that. So we're going to use our glyphs vector, and we're going to be sorting from glyphs.begin to glyphs.end. And we'll put one more comma there. Let's go ahead and copy this. We need all 3. And there is a 3rd parameter. Now the third parameter, if you mouse over, it's actually giving me just a bunch of errors, but the third parameter is a predicate, also known as a comparator in Java, I believe. And what it is it's going to be a function that we pass into stable sort. You actually pass the function in, and it will use that function to sort. And what it's going to do is it's going to be what determines if one element is greater than or less than another. So if we're sorting by texture, we're going to check if the texture is greater than or less than or whatever. If we're sorting by back to front or front to back, we're going to be checking the depth value, and that's what determines how we sort. So we first need to create those functions, and we can create them as just some static private functions. And it needs to return a bool. So we're going to say static bool, and we're going to say compare front to back. And it takes two parameters. It's going to take 2 pointers of glyph type. Since we're sorting this vector of glyphs, naturally you're going to have glyph pointers. So we're going to say glyph star A and glyph star B. And let's go and just copy this twice. So we have compare front to back, we have compare back to front, and we have compare texture. Let's go ahead and define these in the CPP file. So grab all that. And whenever you put static functions in the CPP file, you don't need to include the static keyword. You actually shouldn't. Let's put SpriteBatch there as well. And let's put our curly braces. All right, we're getting fairly close here. There's a little bit of work to do left. Okay, so compare front to back, back to front, and compare texture. For compare front to back, we want to return if, I think we're going to want to return true if the value of A's depth is less than the value of B's depth. Or, I don't know, we may have to just guess, and then we'll have to change it later. So return, and we're going to say is A arrow depth less than B arrow depth. Okay, so what this is it's a Boolean statement. If A's depth is less than B's depth, it's going to be true. And the sorting algorithm, this std stable sort, is going to use that information to move our little glyphs around in our vector. It's going to swap them around. And we can copy this and just change it from less than to greater than here. And then finally, for the texture one, instead of comparing depth, we're going to compare texture. And texture is an integer, so textures can be less than or greater than others. In this case, it's just going to sort them by their texture ID. So if it has a smaller texture ID, it'll get drawn first. This is mainly to keep it so that all of our textures are drawn together in one batch if they're all the same. And that'll keep us from using more batches than we need. All right, so now we just pass these functions in. So for back to front, we're going to say compare back to front. For front to back, we're going to say compare front to back. And for texture, we're going to say compare texture. Now you can use this std sort and std stable sort to sort all kinds of different things. You don't have to just sort vectors of pointers. You can sort vectors of objects and all that. As long as you build these comparator functions, it'll know what to do. And you don't even need a comparator if you're just sorting plain old integers or something like that, because it already knows what to do for those. Alrighty, so let's go ahead and make a call to sort glyphs in end here. So we're going to say sort glyphs. Now we need another function that's going to create the batches for us. So this SpriteBatch, remember, like I said, it can have multiple batches that it actually ends up drawing. So we need to actually store all those batches and create all those batches before we draw them. So let's go ahead and make another class. And let's make the class right here. We're going to say class, we'll say render batch. Sounds like a good name for it. And the render batch is going to store the information about what it needs to render. It's going to store the specific offset into this vertex buffer object. We can actually draw with an offset.